Welcome. Let's take a look at applying the properties of definite integrals to some examples. We have the graph of a function here on the right. Note that this graph is not drawn to scale. And we have the area of the various regions between the function and the x-axis indicated in the upper right corner. So our first example is the integral from 0 to 4 of f of x dx. So we're looking at the interval from x equals 0 to x equals 4. From x equals 0 to x equals 4, we see that this area 1 is created between the function itself and the x-axis. And over here we can see that the area of that region is 8. So the integral from 0 to 4 of f of x dx is 8. Our next example is the integral from 4 to 7 f of x dx. So this time we're looking at the interval starting at 4 and ending at 7. Looking at our graph, here is 4 and here is 7. And so on this interval, we're looking at the area between the x-axis and the function. Notice that that area lies below the x-axis, and for that reason, this area will be assigned a negative value. This is area 2, and we look at our data up here, and we see that that's 3 square units. So the integral from 4 to 7 of f of x dx will be negative 3. Our next example is the integral from 4 to 11. So the interval that we're looking at on the x-axis is from x equals 4 to x equals 11. And notice that this spans 2 different areas. So what we will need to do is to break this integral up into a sum that captures what's happening on the interval from 4 to 7, and then from on the interval from 7 to 11. So this is going to be the integral from 4 to 7 of f of x dx plus the integral from 7 to 11 of f of x dx. Now on the interval from 4 to 7, as we noted, this area lies entirely beneath the x-axis. So this area will be assigned a negative value. So this will be negative 3 plus, and then from 7 to 11, that's area 3, and we can see that that is 5 square units. So this will be assigned a value of 5. And negative 3 plus 5 is 2. So the value of the integral from 4 to 11 is equal to 2. Looking at our next example, we have the integral from 7 to 0 f of x dx. Notice that the order of integration is reversed. In other words, we're starting at 7 and integrating towards 0. So what we'll do is we'll reverse the order of integration, apply that property that basically says this integral is the opposite of the integral with the limits of the integration swapped. So it's the opposite of the integral from 0 to 7 of f of x dx. Now if we're looking from 0 to 7, notice we do have 2 distinct regions to deal with. So we will need to break this integral up into 2 separate integrals. One that looks over the interval from 0 to 4, and the other that looks at the interval from 4 to 7. So this would be the opposite of the integral from 0 to 4 f of x dx plus the integral from 4 to 7 f of x dx. So we have the opposite of. From 0 to 4, that's area 1, and we can see that that is 8. Plus, from 4 to 7, this area, which is below the x-axis, so that's going to be plus a negative 3. So 8 plus negative 3 is 5. And then we take the opposite of that. So the value of this integral is negative 5. Our next example is the integral from 4 to 13. From 4 to 13, notice we have 3 separate regions represented. So we'll have 3 separate integrals, one from 4 to 7, one from 7 to 11, and the third from 11 to 13. So this is the integral from 4 to 7, f of x dx, plus the integral from 7 to 11, f of x dx, and then plus the integral from 11 to 13, f of x dx. Now, we've looked at this integral from 4 to 7 multiple times. We know that that is negative 3. The integral from 7 to 11, that's going to be this area 3, which is 5. And then the integral from 11 to 13, that's this area 4. And notice it does lie below the x-axis, so that's going to be a negative 2. And so we have negative 3 plus 5 plus negative 2, which is 0. So what this means is that the area above the x-axis is the same as the total of the two areas below the x-axis. We have the integral from 7 to 13 of 3 times f of x dx. So first thing we'll do is factor out that 3. So we have 3 times the integral from 7 to 13 of f of x dx. And then as we look at the graph, we see from 7 to 13, 2 separate regions. So we will have to split this into an integral from 7 to 11, and then from 11 to 13. So this will be 3 times the integral from 7 to 11 f of x dx plus the integral from 11 to 13 f of x dx. That gives us 3 times from 7 to 11 is above the x-axis, area 3, and that is 5, plus integral from 11 to 13, that region's below the x-axis, so this will be assigned a negative value, and it would be negative 2. So we have 3 times quantity 5 plus negative 2, which is 3 times 3, which is 9. I hope you find this helpful.